Hello everyone, we are group 15 and our topic is course recommendation system using RAGs and LLMs. My group members' names are Chinmay Kulkarni and Shriyanand Bharadwaj. So I'll just start with the introduction. So welcome to the exciting session where we'll begin and explore a course recommendation system which is powered by cutting edge AI technologies like RAG, which stands for Retrieval Augmented Generation, and LLMs, that stands for Large Language Model, and Pinecone, which we will be using as a vector database. The purpose of this project is to kind of help students and learners easily find the most proper and relevant course which are tailored to their needs. There are so many online courses platform like Coursera, Udemy, edX, and many more websites as well. So we often face challenges like finding courses that meet their specific skill requirement. The second challenges faced might be comparing courses based on parameters like rating, reviews, price, and content quality. And the third one might be avoiding information overloaded. The next one would be our course recommender system also simplifies this process by integrating data science and machine learning techniques to deliver contextual recommendations. Then we will also dive into how we make this possible by combining RAG, LLMs, and Pinecone as a vector database. So first, we will start with explaining a RAG, LLM, and Pinecone. Let's begin by understanding the key technologies like power this system, that is with RAG, and large language models, and Pinecone as a vector database. So we'll start with what is RAG. RAG is nothing but retrieval augmented generation. It is a powerful technique where we combine a database of knowledge with a generative model like GPT. In our project, we retrieve or fetch relevant course information like titles, description, reviews, course URLs from our knowledge base, which is stored in a Pinecone. Generation uses an LLM to process the fetched data and answer queries in a natural and human-like way, which a person can understand. For example, when you ask what is the best Python course, RAG retrieves relevant information from the database and lets the LLM format the answer intelligently. Next, we'll move forward to LLMs. What are LLMs? LLM stands for large language models. Some of the examples of LLMs are OpenAI's GPT-4, which are highly advanced AI models and trained on massive amounts of data sets. In our system, LLMs generate embeddings for user queries and course descriptions. These understand the context and provide highly relevant responses based on user preferences like price, ratings, descriptions, and reviews. Next, we'll understand what is Pinecone. Pinecone is nothing but a vector database which is designed for fast and scalable storage and retrieval of embeddings. Embeddings are nothing but a numerical representation of the textual data, enabling us to compare how similar two pieces of text are. Some of the benefits of Pinecone as a vector database would include scalability, since it is able to handle large data sets, high-speed retrieval, integration with AI models. So together, RAG, LLMs, and Pinecone form the backbone of our course recommendation system. So we'll start with the pipeline overview. The first step would be our data collection. So we started our data collection first through web scraping. We got a link that helped us scraping the titles from the web. And the second thing we got our data from was Kaggle. There we had a database for edX, for Udemy, and Coursera. Then we appended this data set using various ML libraries like Pandas, NumPy. So this is our data which is combined. Then we pre-processed it into our JSON format, which is compatible for any vector embedding that we have. So here is the JSON format of our data set, which is cleaned and properly handled. Then I'll just show you the pre-processing parts. Now we will go to the embed.indexpy, which will be explained by Chinmay.
Yeah, so for the embedding part of this project, we have used the Pinecone as Praniti mentioned earlier. So let's take you to the Pinecone index part where the course recommendation project index was made. So here we require Pinecone environment as well as the Pinecone API key, which is necessary to connect this particular setup from the system and load our particular embeddings to this particular pinecone in the vector format. So these vectors will be used further to retrieve the whole embeddings, then create a contextual data understanding for the particular model, in which the RAG will put the query from the user and the response will be generated based on this embedding from our database. So these are the particular embeddings which we have created, which is the in short vectors in the database, and the total number of record counts are 8370, which has been loaded over here. So yeah, I will just show you further about how the embeddings were created. In the embeddings, we have taken the Pinecone API key, the Pinecone environment, which was set, and the OpenAI key to convert these embeddings. So OpenAI, in this OpenAI particular format, which we have used the model to embed this particular whole data, is text embedding ADA002. This was the particular model which we used, in which we combine the fields like course title, rating levels of the course, the instructor, the duration, to complete in weeks. Further, the embeddings are loaded into a JSON format so that the embeddings can be extracted further for the retrieval of data, and then those particular embeddings which we have, they have certain vector values which have been stored, from which the context makes the whole sense for the data. Further moving on, we'll see that how the Pinecone utilities are used further to fetch the embeddings. In the Pinecone utilities, we have initialized the Pinecone, get the index which we have defined further, pass the metadata text. In the past metadata text which we have taken certain to show for the use case is like course title, rating, level, instructor, and duration. So the query, so this is the query in which we go to the Pinecone vector database, query that Pinecone database, get all the data from it, make the dot product, which helps to make the cosine similarity, which is like the probability type of thing for that particular word embedding which we are going to make. Then further moving on, we'll go to the fetching part of the embedding, in which we are using the same index which I created. The embeddings have been fetched here. The embeddings which are fetched from the all embeddings JSON. So in all embeddings JSON, as we can see, this is the metadata, and these are the embeddings for particular database which I have stored on the Pinecone. Means whole data is been particularly embedded over here. Then we fetch the data. This data has been saved, and then moving on further, then we integrated the LLM for this particular vector embeddings. So the vector embedding part, so just to show first, these are the particular environment variables. As it is secretive files, we cannot show that, but we have stored in the environment file, and then we have used this. So we are not directly hard coding or putting the particular keys into the environment, which is not a suggested practice. Then further over here, the embeddings which we have created through the text embedding ADA model have been retrieved over here. The function for the enhanced context with GPT, we are using the particular relevant features, these which are given over here, and if they are not matching with it, then the context will say no relevant course found in the knowledge base, if there is no certain relevant course matching in our database. And it will go to the ChatGPT model to further retrieve whole thing from the live data, and then it will suggest the particular courses to the user, which is like this particular part where we get, which is the enhanced recommendation, not from our database. It is from the ChatGPT learning from our database and then giving certain suggestions to the user. Then we have hosted the application on the Streamlit, which is an interactive particular dashboard kind of thing, in which the user can put his particular query, and which can go to this particular embedding part, run through the racks, whole process, and then it will go to the LLM. LLM will understand the particular query, what is the user's need, and then accordingly it will give it a response. So for the Streamlit part, I will further give this whole project towards Sri, and Sri will guide you through the Streamlit part.
As you can see, we have created this dashboard or a Streamlit application. Here we have given a dialog box which tells us about in which we can enter the courses we would like to have information about. For example, if we use fashion as design course, our okay. So as you can see in the terminal, okay, as you can see, the embeddings are being generated here, and for the coding part of the Streamlit user interface, we are here inputting all the necessary libraries, and we are using the OpenAI API key that was present in our environment file that we showed you, and we have also created this error message. If Open API key is not found, this message will pop up. And this is all the user interface for the Streamlit application. And as you can see, the information was being retrieved, and our application has given us top 5 recommendation for the fashion as design course. And here the GPT, and here also we have the GPT model recommends us the top 3 courses that were put by us for the fashion course. Yeah.
So yeah, as she mentioned, for the Streamlit part, whenever we put the course's name, it suggests the particular courses which we have given to it, and the particular features which we have, the rating, the level, the instructor, and the duration of the course. The user has the flexibility to put the rating and then get accordingly the particular ratings which he can use for his benefit, and then take the courses as per his need. Also, if the particular beginner is a beginner level starting with the new thing and he want to explore the particular things like the fashion design, machine learning course, or for the architecture part, he can select the level which is beginner. If he is like knowing the whole starting level, the basics, then he can choose the intermediate level. Same for the instructor. If he is under any particular professor or under particular uh, means if he had read any something article about the particular instructor, he can choose the instructor and then find only that particular instructor's course, which can vary a large, like from the fashion. And if the instructor is teaching mathematical, he can teach can take that particular course as well. And for the duration as well, he can select the duration. And for the particular future scope part, we have kept some future scopes which Praniti will tell us.
Some of the future scope would be like getting more data and handling it correctly with the proper JSON file or whatever the text formats we have. Additional would be taking a big model like the GPT is trained on, like as we know, LLMs are trained on gigabytes and millions of data points. So we can also have that, considering all our needs, like whatever we want. That's it.
Yep.